So hello and good morning to everyone. So today's lead code question is 3312, which is sorted GCD pair queries. So basically in this question we are given an integer array nums having length n, and with that we are also given an integer array queries. Now what G so let GCD pair denotes an array obtained by calculating the GCD of all possible pairs of the nums array, right? So what we do is in the nums array we'll take every possible pair, then calculate the GCD of that pair and store those GCD pairs in the array GCD pairs, and then we'll sort those pairs in the ascending order. So that is our GCD pairs array, right? That is our GCD pairs array after the sorted, right? So we get the sorted GCD pairs array, right? Now what we have to do is for each query queries of I, we have to find the element at the index queries of I in the GCD pairs. So suppose if queries of I value is 5, then we have to return the element at index 5. We have to return the element at index 5 present in the GCD pairs array, right? And so now at the end we have to return an integer array answer, where answer of I is basically the value of GCD pairs at queries of I for each query, right? So let's move to the example part to get the question more clearly. So here we are given the nums arrays 2 3 4. So first thing that we get is we get our pairs array GCD pairs array. For that we have to form all the pairs. So the pairs are 2 comma 3, 2 comma 4 and 3 comma 4. So these are the three pairs. Now we have to find the GCD of these pairs. So GCD of this pair is 1, GCD of this pair is 2, and GCD of this pair is again 1. So these are the GCD of all the pairs. Now what we have to do is we have to sort the GCD values. So after sorting we'll get 1 comma 1 comma 2. So now this array is the GCD pairs array. Now once we get the GCD pairs array, next thing what we'll do is we'll answer the queries. So if you'll see the queries, first query of 0 is 0, so we have to return the element that is present at 0 in GCD pairs, so that is 1. So answer of this query is 1. Next we have index number 2. Next is 2, so we have to return the element present at index number 2, which is 2. So the next is 2, again 2, so again answer is 2. So we get our final answer, that is 1 comma 2 comma 2, right? So this is basically the question. Now if you see the constraints, n, which is the length of the nums array, it can be up to 10 ki power 5, and each value in the nums array can be up to 5 into 10 ki power 4, and the total number of queries can also be up to 10 ki power 5, right? Or n into n minus 1 by 2, like whichever is the minimum of n into n minus 1 by 2 comma 10 ki power 5, right? Whichever is having the minimum value, that will be the total number. Oh, sorry, I get it wrong. The total queries can be 10 ki power 5, and the index value or the value in the queries array can be n into n minus 1 by 2, right? So let's move to the approach part. So initially when we see the problem, it will look like easier that take every pair, get the GCD of that pair, then sort all the GCD values, get the array, and then using the array answer the queries, right? So this is the whole scenario that is given to us in the question. But the first thing, that is generating the pairs. So here the nums length is n, which is less than or equal to 10 ki power 5. So if you'll see what are the total pairs is basically n into n minus 1 by 2. So this is the total number of pairs. So for n is equal to 10 ki power 5, the total pairs are 5 into 10 ki power 9, right? So the total pairs are too large. So if we generate all the pairs, then we get TLE for sure, right? So there is no way in which we can generate all the possible pairs, right? So we have to think of something else, right? So now let's say if we somehow know how many pairs have GCDG, right? if we somehow get if we somehow get this thing, that is how many pairs have the GCD value G. Let's say, suppose if we know that GCD is equal to 1 has 8 pairs, GCD with 2 has 5 pairs, GCD with 3 has 2 pairs, and GCD with 4 have 1 pair. So then automatically we get our sorted GCD array as first 8 values will be 1, right? This 8 values will be 1. Then next 5 values in the array will be 2. These are 8. Next 2 values will be 3, and next one value will be 4. So we get a sorted array, right? So if he somehow get that how many pairs have the GCD value equal to G, if we get the count of the pairs, if we get the count of the pairs having the GCD value, we will get our sorted array directly, right? So now, and then there will be no need to build our actual array by taking pair, finding their GCD, and then sorting them, right? There is no need, right? So now our focus is on finding how many pairs have the GCD value equal to G. So this is what we have to find right now, right? So for this, what we'll do is, the first thing that we'll do is we'll count the numbers divisible by every value, right? Suppose we have the nums array as 2 comma 3 comma 4. Now if I ask you, in this nums array, how many numbers are divisible by 1? How many numbers are divisible by 1? So 2 is divisible, 3 is divisible, 4 is divisible. So by 1, all the 3 numbers are divisible by 1. Then if I ask you how many are divisible by 2, then 2 is divisible and 4 is divisible, so 2 are divisible by 4. Then how many are divisible by 3? So 1. How many are divisible by 4? So 1. So this way we'll find or we'll count the numbers divisible by every value, and this value will go to up to the maximum value that is present in the array. So up to the max value, right? So we'll store this as in a new array divisible count of G. So what this will tell, it will tell the number of elements in our in nums array number of elements in nums array that are divisible by G, divisible by G, right? So first of all we'll find this, that div count, right? So to find the div count, which will store the frequency of numbers that are divisible by G. So for this what we'll do is, first of all we'll find the frequency of each number in the nums array, right? So first of all we'll store the frequency of each element in the nums array, and then to find the frequency of the numbers divisible by a particular number G, what we'll do is, we'll start dividing from G is equal to 1 and all up to G to max value, all up to maximum value present in our nums array. And now suppose what we do is, now suppose we are dividing from 3, so what are the numbers that are divisible by 3? So 3, 6, 9, 12, and so on up to the maximum value. So if we'll take the frequency of the numbers present, frequency of 3, frequency of 6, frequency of 9, frequency of 12, and then we'll sum those, so then we'll get the count of the numbers that are divisible by 3, right? So here we are doing the same thing, that suppose if you have to check the divisibility by Z, then what we are doing is, we are checking the frequency of g, then frequency of, then we are incrementing x by g. So first frequency of g, then 2z, then 3z, and then 4z, and so on, right? So this way we'll find the frequency of numbers that are divisible by g, that are divisible by a number g, and g can be anything. So g will be from 1 to maximum value, 1 to maximum value, right? So this will be our first thing. Then so we get the, so now we get the count of numbers that are divisible by g. Now our next goal will be to find the, to find the pairs, to find the pairs having the gcd value equal to g, right? So for that we already have, we already have the numbers that are divisible by g, right? Right, so what we'll do is we'll count the all the possible pairs. So right, so div count of g will give us the numbers, will give us the frequency of the numbers or the count of the numbers which are divisible by g. So now every pair, every pair among that numbers will satisfy that. So suppose let's say we have taken an example. Suppose here we have the nums arrays 2 4 6 and 8. Now for g we have taken g is equal to 2. So what will be div, what will be div count of 2? That is how many numbers in the nums array are divisible by 2. So 2 is divisible, 4 is divisible, 6 is divisible, 8 is divisible. So div count of 2 will become 4. That means all the, that means in the nums array four numbers are divisible by 2, right? So now how many pairs, how many pairs or how many possible pairs are there in which both the numbers, in which both the numbers are divisible by 2? So here see, pairs are 2 comma 4, 2 comma 6, 2 comma 8, 4 comma 6, 4 comma 8, and 6 comma 8. So these are the pairs in which both the numbers are divisible by, both the numbers are divisible by 2. So here we have four numbers divisible by, four numbers divisible by 2. So as we know, here we are taking both the numbers that are divisible by 2. So we'll be taking from those four numbers only. So the number of pairs will be 4c2, right? So the number of pairs is 4c2, which is 4 into 3 by 2, that is 6. And here we can see we have 6 pairs, 1 2 3 4 5 6, right? So we have total 6 pairs, we have total 6 pairs in which both the numbers are divisible by 2, both the numbers are divisible by 2, right? But what was we are trying to find, we are trying to find the pair where the gcd value is equal to z. So here our g is equal to 2. That means we are trying to find the pairs where gcd is equal to 2, right? So let's see all the pairs. So if you see all the pairs, does they have gcd 2 only, right? So here pair is 2 comma 4, gcd is 2, 2 comma 6, gcd is 2, 2 comma 8, gcd is 2, 4 comma 6, gcd is 2. But if we see, if we see the pair 4 comma 8, so see both the numbers are divisible by 2, but their gcd value, but their gcd value is not equal to 2, it is 4, right? So 4 comma 8 has a gcd value 4, not 2, right? So when we have counted, when we counted the possible pairs, when we counted the possible pairs, we have counted this also, we have counted this also, right? So now the pairs, now the pairs which are divisible by 2, now the pairs which are divisible by 2 will contain the pairs with gcd 2, pairs with gcd 4, and pairs with gcd 6, and so on, right? So the possible pairs or the pairs that we get that are divisible by 2 doesn't mean, it doesn't mean that they have all the pairs that have gcd 2 only. So they can have gcd, suppose if a number is g, if a number is g, then the pairs divisible by g can have a gcd g, 2z, GCD 3Z, right, and so on. So if we'll see this as mathematically, then pairs divisible by 2, pairs divisible by 2 can have exact 2, exact 4, exact 6. Now what is exact of G? Exact of G is basically pairs having GCD Z. So exact of 2, exact of 2 will give us the count of the pairs having GCD equal to 2, right? So pairs divisible by 2 can have those pairs having GCD 2, can have those pairs having GCD 4, and can have those pairs having GCD 6, right? Now what is our goal? Our goal is to find, our goal is to find the pairs having GCD equal to G, having GCD is equal to G. And in our current example, we have G is equal to 2, we were having G is equal to 2. So now what we need to find? We need to find the pairs that have GCD 2, right? To find the pairs having, so to find the pairs that have GCD is equal to 2, we'll take all the pairs which are divisible by 2, which are divisible by 2, and then from those pairs we'll subtract those pairs that have GCD equal to 2Z, GCD equal to 3Z, GCD equal to 4Z, and so on, right? So let's see the code part. So basically we have discussed that exact of G is basically the number of pairs whose GCD is equal to G. So for that we already find the div count of G, which will tell us the number of number of which will tell the count of numbers that are divisible by G, so if we'll form all the possible pairs, if we'll the form the all the possible pairs, so that will be, so div count of G C2. So let's say this will be n, so it will become nC2. So that is, so nC2 is n into n minus 1 by 2. Here n is div count of G. So if you have to find exact of G, then we'll take all the pairs divisible by 2, that is, this is these are the these are all the pairs, which are divisible by G. And now we have to find exact of G, so we have to subtract exact of 2Z, exact of 3Z, right? So we are subtracting exact of 2Z, exact of 3Z, and so on from the exact value of Z. So after this loop we'll get exact of G for every G from 1 to maximum value, right? And this exact of G will give us the of count of pairs having GCD equal to G, right? So how we reached up to this point? So first what we have find is, we have find the frequency of each number x, then using that frequency we have found div count of G. So div count of G will tell us the count of numbers which are divisible by G, and now using this div count, what we have found? We have found exact of G. Exact of G is basically the count of numbers having GCD equal to G. So to find exact of G, what we'll do is, we'll take all the possible pairs that are divisible by G, which will get from this div count of G, using div count of G C2, and then we'll subtract all the we'll subtract those pairs that do not have GCD equal to G. So we'll subtract all the pairs that have GCD equal to 2Z, 3Z, 4Z, and so on, right? So once we get the count of all the pairs having GCD G, now let's say, suppose we get this, that GCD is equal to 1 has 5 pairs, GCD equal to 2 has 3 pairs, GCD is equal to 4 has 2 pairs. That means exact of 1 is equal to 5, exact of 2 exact of 2 is equal to 3, and exact of 4 is equal to 2. We get this thing. So how our sorted GCD array will look like? So for 1 we have 5 pairs, so 5 times 1. Then for 2 we have 3 pairs, so 2. There are 3 numbers having GCD 2. Then there are 2 numbers or 2 pairs having GCD 4. So this will be our sorted GCD array. This will be our sorted GCD array. So now, instead of making the array like this, or instead of storing the total array, what we'll do is we'll build the prefix sums, right? So how many numbers, how many pairs have GCD 0? 0. How many pairs have GCD equal to 1? So 5 pairs. How many pairs have GCD equal to 2? 8. How many pairs have GCD equal to 3? That is 2. But we'll take the all the values, so 10. So this is the prefix, this is the prefix array built over the built over the exact array built over the exact array, right? So now our every query will become simple for us, like at which GCD value does that particular index falls, right? So that will answer using the binary search. So we'll apply binary search on the over the prefix array, will over the prefix array, right? So let's see how we'll do that, right? Suppose now let's say we have the sorted GCD arrays this way, right? So what will be our prefix array? For 0, 0. For 1, up to 1 we have 5 numbers, up to 2 we have 8 numbers, and up to 4, up to 3 we have 10 numbers, right? So now let's say, now suppose we have to answer. So our query is, let's say, 7, that is our q is equal to 7. So we have to return the GCD value present at index number 7. So that is 2. Sorry, that is 2. 0, 1, 2, 3, 4, 5, 6, 7. So at index number 7 we have GCD is equal to 2. So now let's see how we'll answer that using the prefix. So first of all, what we'll do is we'll find the, in the prefix array we'll find the first number which is greater than q. So the first number greater than 7 is 8, which is 8. So we get 8. Now at what index 8 is present? 8 is present at index number 2. So that is our answer. That is our answer, right? So see, if you'll see the code part, we have taken the prefix of g. So first of all, we'll build the prefix array over the exact array, over the exact array. So once we build the prefix array, then we'll answer all the queries. So for queries, we'll get our index q, and then we'll use the lower bound. But here, if you'll see, we'll applying lower bound on q plus 1, not q. That means we are trying to find the first number which is greater than q, not equal to q, which is greater than q. That's why we are applying lower bound on q plus 1. So what it does is it will give us the index of the first number having the value greater than or equal to q plus 1, greater than or equal to q plus 1, and then we get our index, and that will be our answer, right? So if you'll see the whole code in one go, so the first thing that we have done is we have find the maximum value from the nums array, and then after finding the maximum value we are storing the frequency of each number, present in the nums array, and then using that frequency we are finding the frequency of number which are divisible by a particular number g, right? So for that what we are doing is we are applying a loop from g is equal to 1 to maximum value, and then in the inner loop, we are taking the elements that are divisible by particular g. So suppose if our g is equal to 3, then we are taking the elements 3, 6, 9, 12, and then we are taking the frequency of these numbers, right? So the sum of these frequency will give us the numbers. Sum of these frequencies will give us the numbers divisible by 3, right? And then once we get the div count, now next thing that we need to find is the number of pairs which are exactly divisible by g, right? So for this what we have done is, so exact of g is basically total pairs, total pairs, total pairs divisible by g minus those pairs whose GCD, minus those pairs whose GCD is not equal to g. That means their GCD is either 2g, 3 into g, 4 times of g, and so on. So we'll subtract those points or those pairs from the total pairs, right? And then we'll get the exact value of g, right? So then we'll find the prefix array, we'll find the prefix array, and then using the binary search we'll answer all the queries. So I hope I'm able to explain the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.